Hi guys, John here. Welcome to the channel. Today I'm going to have a look at how you can achieve a better translucency effect using masked materials for cinematic renders. This is actually the second time I've made this video. I made it a couple of days ago and posted it, but I've since learnt something that made a huge difference, so I thought I'd just redo the video. So let's have a look at this scene. So in this scene, I've got a mirror ball which shows reflections. I've got this green sphere which is an emissive material, and in front of that I've got a plane which has a translucent material which is just scrolling an emissive texture. And in front of that I've got another plane which is another translucent material with a refraction material on it. Okay, so as you can see, we're getting no global illumination from this middle material, which is the translucent sort of electrical material scrolling, and you can also see that the refraction has not factored that in at all either, and there's no reflections on the mirror ball, and this is typical of translucency in Unreal Engine. So I've actually discovered a way that you can use masked materials to combat this issue and get a much better result. So let's have a look at it. So currently this is the material as it is set up with translucency as the blend mode. Okay, so all it is, it's quite simple. It's just a texture. We've got a panner going into the UVs to scroll a texture. We're multiplying the RGB by this value to give us an emissive boost, and I'm using the blue channel to go into the opacity, and the reason why is because this texture doesn't have an alpha channel, and because it's mostly blue I thought the blue channel would make a good alpha. Okay, so if I was to change it to a masked material, let's have a look. And so the pin's now changed to opacity mask, and let's just plug that into opacity mask to start with. Okay, and click save. So immediately in the scene you'll see now we've got some reflections, and we've got global illumination, which is also casting light onto the refraction, and you can see that. But the opacity mask is sort of clipping it, because you can only have a pixel which is invisible or visible, so there's kind of a cut off. I think it's around about halfway between 0 and 1. It decides, whether it's going to be visible or not, that pixel. Okay, so the node that I want to show you is, if you right click and search for dithering, or sorry, just dither, and you've got dithertemporalAA, and this is a material function, and we'll have a look inside that in a bit. But what this does is it basically, you plug in what you're using for your alpha here, and then you plug the result into your opacity mask, and let's just save that and see what happens. And now you can see that it's adding noise into the areas that were switched off before. And this control, this pin, random, if I just right click on that and promote to parameter, and then just save it again, and then if I increase that, you can see that it's sort of controlling the density of the noise in those masked out areas. So all it is each pixel of noise is basically just a pixel which is lit, and then you've got pixels around that which are still unlit. So that's how that is working. I found the sweet spot for this texture was actually around about 6, so it's nicely lit. It doesn't look too great at the moment, and if you were to use this just in runtime, you're going to get a result like that, which is a little bit noisy. You can play around. If you go to your project settings, and then have a look for your, if I spell it correctly, anti-aliasing. You can change your anti-aliasing method here, and you'll see that that does actually have an effect on it, but it's still fairly noisy. Okay, but if you're rendering out for cinematics, then we can make use of the anti-aliasing and the amount of subsamples to try and get rid of that noise quite a bit. So let's go to Window, Cinematics, Movie Render Queue. Okay, I'm just going to ignore that one for now and add in a new one. So this is our level sequence. So I've rendered this sequence out already, and I've used EXR as the file format, and my settings for anti-aliasing, I did 1/64, so 64 temporal sample count. And when you add that, you're going to get this message saying that the spatial sample count multiplied by the temporal sample count must not exceed the current value for r.temporalAA samples set in your project config, or you can change it via console command. So it's currently set to 8, but we want it set to at least 64. Okay, so to do that in MRQ, Movie Render Queue, click on Setting and come down to, where is it, Console Variables. Just click on that. You see where it says Console Variables, just click plus there, and then we can search for r.temporal, and it comes up there, AA samples, and just change that to 64. Now it's not going to get rid of the warning because it doesn't realize that we've entered that in, but once you start doing your render, then it's going to update this and it's going to render out correctly. Now I have already done a render of this sequence, so let me just show you the sequence. It's just a really simple camera movement, just so you can get an idea of how this works with a little bit of motion. Okay, so I've overridden anti-aliasing, and then you've got your anti-aliasing method that then you can apply to it. And the initially I've done a render without any anti-aliasing, and then I've gone through each of these to see what kind of result it gives us. So if we go over to Davinci Resolve now, we can have a look and see how this rendered out. Right, so we're over in Davinci Resolve now, and I've just put in all the different renders that I've done, and I've also done this one as just a reference. This was the translucent material before I added the node to it and changed the blend mode, so you can see what that looks like. So yeah, no global illumination, no refraction, no reflections, and the next one that I did was a render of the same sample count settings set to 64, but with no anti-aliasing method. And you can see that it looks quite noisy. If we zoom in, you can see how much noise there is. But another thing is I found is the colours don't look very accurate. Like the blue seems to be sort of less saturated or more sort of greenish, which is kind of interesting. And then I did the FXAA, I think, which is fast approximate anti-aliasing, and the result of that is pretty similar to no anti-aliasing. And then we've got the TAA, the temporal anti-aliasing. Now the colours on this look way better, and the noise is a lot less pronounced. If we zoom in, you can see the noise way better than what it looked like in the editor, but it's not amazing, it's still visible. But one thing that I did notice is when you scroll past that refraction mesh, you're getting this kind of smearing on the edge of it. It's like a ghosting effect that doesn't go away, which is not great. So let's have a look at the MSAA, which is multi-sample anti-aliasing. And again, it looks similar to the no anti-aliasing that we had before, like the same sort of distorted colours and loads of noise. And then the next one, which is the temporal super resolution anti-aliasing, which actually gives us the best result, and you can see why Epic uses this now as its default anti-aliasing method, because it's really good. A little bit noisy still, but way better than what we've seen in the other renders. And if you scroll, we've also got rid of that horrible ghosting effect. Maybe there's a little bit, but it's hardly noticeable. So when you look at the noise, you zoom into it and scroll along. I don't know if you can see that on YouTube. Hopefully, if I zoom in a lot more, you can basically see that the noise pattern doesn't move. It's sort of fixed in place on the screen. Now I thought to myself, there's got to be a way that you can kind of cancel that out, because it's not moving anywhere. So there must be some way that you can approach that and cancel out that noise. So I had a little play around with the node and inside it, and figured out a way to do it, which I'll show you in a minute. But this is the result that I got from doing that mod, and you'll notice that it just looks way cleaner. If I zoom right in and then we compare the two, hopefully you can see that. Yeah, the noise is, there's still something there, but it's nowhere near as bad as it was before. And actually it just looks more like film grain now, so that might be, it might be fine to not even add any more processing to this shot. So how did I achieve that? Okay, so if I go back into the material, let's have a look. So back into our material now in Unreal, and if we just double click on the dithertemporalAA node, you can have a look and see you've got this texture here, And this is a noise texture, and basically it's the noise texture that you were seeing on screen when we zoomed into Davinci Resolve. So the pixels of this noise texture will always stay in the same place, and that's because it's using this material function to map it. And this material function has got this input here, which is a constant 2 vector, and you see the values are 64 and 64. Now those values are basically the resolution of the texture. So what I thought was, if there was a way that we could invert the noise texture and flick between the non-inverted version of it and the inverted version of it at a rate that matches our subsample count rate, then we should be able to sort of average out that noise and cancel it out. So what I did was I created a copy of this material function, and if you go here you can have a look, and I just took that red pin and just inverted it and then put it back through. Now if we go to our original material, you can have a look at how I set that up. So here's the non-inverted one and here's the inverted one, and we're using this lerp node to basically switch between the two, and this is what's creating the pulse. So we've got our time node, and our time node is basically time in seconds, yeah, and if we want to increase the rate of that, then we need to multiply it by a value. So I'll come to this value in a moment once I've gone through the nodes. So if we then multiply it by that value, then put it into a sine wave. Now the sine wave is an oscillation that starts at 0, goes up to 1, and then goes down to -1. So it's got a range of 2 basically, which is a little more than what we want, and we don't want it to go into negative values either. So the way you fix that is you divide it by 2, so the range is now 0.5 to -0.5, and then if we add 0.5 to it, then it puts our oscillation in a range of 0 to 1. And then if we put that into a step node, what the step node does is the value set by here, x, is basically so when the input is below that value, it returns a value of 0. When it's above that value, it returns a value of 1. So as it's oscillating, it will create a digital pulse, okay? And the value here I calculated by multiplying the subsample count by the rate of the shutter speed, right? And if you want to know what your shutter speed is, so I've missed something there, but I'll come to it in a sec. If you want to know what your shutter speed is, just go to your camera and type in shutter, and then you'll see what it's set there. It's currently set to 60, so it's 1/60th of a second, and that is about right for doing any kind of videography work. You would have your shutter speed duration should be about half the length of your frame time, and that's just so you can get like better, like more accurate motion blur, and you don't get like flickering when things are moving about. So if we come back to the material, so I've taken that shutter speed and multiplied it by the subsample count, but then I've divided it by 2. And the reason for dividing it by 2 is because this series of nodes with the sine wave creates a full oscillation where it goes from 1 and back down to 0. So we're getting 2 pulses. So I've divided it by 2, and so that value should now match the subsample rate. Okay, so I might as well just add this, in Movie Render Queue, when you see your subsamples counting up when you're rendering, you'll notice that once it's rendered your subsamples, you'll see your animation jump forward a little bit, and that's because the subsamples happen during the shutter exposure. So if you were to take your duration of your shutter exposure and divide that by 64, then you get the time of each subsample. And yeah, so that's basically how I've done it. And I've just taken it one step further and created a single material function to do the whole of it as sort of one node, which I'll put a link to actually in the video description. So if you want to try this out, you can just grab that node and connect it up, and I've got it down here somewhere. So simple, all you do is you connect your alpha to this pin, and then you connect a constant value or a scalar value to this one for your shutter speed, and you can enter in your shutter speed, and then you want to do the same and enter in your subsample value that you're using in Movie Render Queue. And then here you've got a pin for your noise density, so as you increase that value, then the amount of noise will change, and then you just connect that to your opacity mask. So with that out of the way, I'm just going to show you a use case scenario where I've used this myself recently to do a cinematic render of something, and how it's helped me to achieve that by using masked materials. So back over into Davinci Resolve now, and this is part of a project that I'm working for a video client of mine called Art Tourist, and in this scene we're basically travelling down a wormhole. And so what it is I've got this wormhole mesh, which is a long sort of twisty tunnel, and the mesh has 2 layers in it, and each layer has a different material. So the outer layer is in this case it's a masked material with the dithering effect on it, and the inner material is a translucent material with refraction on it. So as we move through the tunnel, you've got this sort of rippling effect just in front of you as you move through the tunnel. And the reason I did use that node is because I needed, or I wanted to see where the tunnel was going through the material. And if I use the translucent material here, then we wouldn't have been able to see the refraction effect. And if I used like just the mask material on its own, then we'd get horrible clipping, or we wouldn't get any translucency. But because of that node, I was able to achieve this shot, and only because of that node I was able to achieve this shot. So yeah, I'll give you a little preview of the shot. Okay, check it out. So yeah, that kind of sums it up. So yeah, if you want to try that material function and see how it works for you, just all you do is download it and just drop it into your project folder somewhere in your content folder, and then you should have access to it. It was done in UE 5.4, but I'm assuming it work in 5.5. I've got 5.5, but I haven't really done much with it because every time I try to do what I want to do, it crashes. So until they sort out the bugs in it, I'm sort of sticking to what I know is a reliable piece of software, and 5.4 so far has been great for me. Just editing this, and I've realised there's something I forgot to mention, and that is if you want to get the reflections to work correctly with this effect, then you need to have hardware ray tracing enabled. So you will have to have a GPU that supports it. But to enable it, yeah, you just go into your project settings and just search for hardware ray tracing, and you should be able to find it. Anyway, if you've got anything to add to this topic, just drop a comment below, and if you liked it, hit the like button and subscribe for more content like this. I'm John from Origenic VFX, and it's easy when you know how.